What's up? Nathan here from P8 Studios. Welcome back to another XNA tutorial. This is an update to the camera sample I did a little while ago. That was for 3.1. I've upgraded that to 4.0 and then I updated it to have a dedicated camera class that you can use. And I'll show you all the stuff you need to do to get that all set up. And then I also added a brand new feature to the camera. So let's go ahead and look at the code really quick, and then I'll show you the completed version. If you see in the 3.1 code, it's it's very similar. Let me go ahead and close out the error list and the output. Okay, so I created a dedicated camera class, and that has a copy of the viewport, which holds the dimensions of the game window and all the other stuff that the viewport contains that you might need. The position right here, that will hold the position of the camera. Now this will be the center point, so if we say 0, 0 as the position of the camera, that will be the center of the viewport we have here. So usually when we pass the viewport, we pass in the graphics device.viewport, so that would be the full game dimensions. But if you want to break that down, you have the option to do so. Now, the feature I added was a camera shake, and I'll get into that a little bit later. But I had to create a saved position and a saved rotation down below. That way, if we have a massive shake, we want to keep. So we have a position, the camera's looking at position 0, 0. So now we have a massive shake. We want to store 0, 0 to its saved position, and also the rotation of that camera in the saved rotation. Because we do the massive shake for 1 second, and we want to come back to that saved position. Because we don't want to do a massive shake and then end up in the middle of nowhere. We want to go back to the original camera position and rotation. So this is what the saved position and the saved rotation objects are for. And the center point, this will be the center focus of the camera. We'll get into that in the update method. We have a zoom scaler, a rotation, and our shake amounts. Now, when we do a shake, we want to shake the position and the rotation by different amounts. Rotation looks kind of weird when you try to shake it. The reason is because you pass it a float value, so 0.5 for the rotation. That's a massive rotation difference because it's assuming it's in radians. Now if you want to build on this class and do it to assume degrees and then convert it to radians, you can. But I thought it was a good idea to separate position shake and rotation shake. And also the maximum amount of time we will shake, so 1 second the camera will shake and then go back. Now you can customize it too. And the transform matrix of that camera. Alright, so we have two constructors. The basic one we pass the viewport and the position. Then we initialize the viewport position. The zoom level will be 1, so 100% zoom. Rotation will be 0, and we initialize the random. We create a new random object. The second and last constructor is more advanced. We pass it a customized zoom level and customized rotation. And it's basically the same thing except for we initialize zoom to zoom and rotation to rotation. Okay, update. Now I wanted to keep this very simple. But at the same time I wanted to keep the shake and the other camera movement separate. So two things that you can think of to make this better, but it's more complex, is camera states. So you say I want to shake, so now the camera state is shake instead of normal. or you can do it in events. So I started a shake, and I do the shake, and then I end the shake, and then at that point, it'll go back to the normal movement. So I wanted to keep this very simple, so I had an if here. If the shake timer is above 0 seconds, we perform the shake. Now, the other reason is because at the end of the shake session, I want to be sure to reset the position and rotation. So I have to do position is equal to saved position, and rotation is equal to saved rotation. Now, if the shake timer is above 0 seconds, we restore the position and rotation, and then we also change the shake timer amount. So then we do another check, and this is where the states and events can come in. We check it if it's above 0 again. If it is, then we do the actual shake calculations here. Now what the shake does is it does random.next double, which means it chooses a random double from 0.0 to 1.0. Now I wanted to shake in a negative value as well. So what I did is I multiplied it by 2, and I subtracted that by 1. So if it chose 0, 0 times 2, that's 0, minus 1, that's negative 1 in the shake amount. So then I multiply that by the position shake amount, and I do the same thing here. So a different random value from the X and the Y. Now for the rotation, it was the same thing, but I multiplied it by the rotation shake instead of the position shake. Okay, if I do not want to shake, if the shake timer is equal to or less than 0, I do the normal movement code here. So I can zoom in, zoom out, Z is zoom in, X is zoom out, move the camera, WSAD, up, down, left, and right. And I do that by a movement vector, and this explains why. Since position is a property and not a direct object, if we go back up here, position is a property, not the direct vector to object. Since that is the case, we cannot use position.y plus equals 56, for example. To counter that, we need to build a movement vector and then update the position based on that movement vector. Okay, and now we get into the center point. This is independent. Both shake effect and normal effect needs to do these two things. So the center point, we calculate the different distance between the position and the view. So this is where I said you can change the view to whatever you want, and then we get a different center value here. And this will be the half of the view, half of the view width, and half of the view height. So the center of the view, and then the distance between those 2 points. Alright, now the transformation matrix, we use it by creating a scale. And now to speed up or slow down the zoom, we do math.power. So zoom, and take that to the power of 10. Zoom, take that to the power of 10, and the z-axis does not get any zoom. The reason these both are the same is because we do not want any stretching. The create rotation, you just rotate it by the rotation value. And create translation, we just negate the center values. Center X, center Y, and 0 for the Z. Now it's best to do that in this order: scale, rotation, Z, and translation. Otherwise, it might do some weird effects. Okay, now we have the shake method. Now we call camera.shake. We need to pass it the shake time, the position amount, and the rotation amount. And that's pretty much self-explanatory. The max shake time will decide how long the shake will last. And then we also need to save the position and rotation. The gameplay object is the gameplay object version 2 I released not that long ago. You can see that on the forums. If you go to the forums and go to PH Studios content here, you'll see an XNA link here. If you click that, you will see gameplay object version 2. Now I created a post with just the class, or I created the attachment there. So you can either download the CS file or copy and paste the text here. So that's the only thing that was changed between that one and version 1 was a matrix for each individual gameplay object and the texture data. Okay, so game 1, we have a graphics device manager, graphics, sprite batch, sprite font to display how to manipulate the camera and player, just what buttons to press. And we have 2 gameplay objects, the player and the background. We need to get the camera object and 2 keyboard states, current and previous. If you want to use the previous, I did not in this code here. Game 1, you've seen this before. We make it 720 HD 720 resolution. Initialize, player, and background need to be new gameplay object. And camera, this is where we pass the viewport. We can manipulate the viewport if we want to, and all that stuff. And we pass it the initial position. Remember, 0, 0 will be the center of the viewport. So, since we'll pass it the default viewport, which is just the game window, vector 2.0 will be the center of the game window. And then we just get the current state of the keyboard. Load content. Now for the background, I used the Bubbles background, the second version of that. Update, we set the previous keyboard state to current and update the current. If current keyboard's escape key is pressed, we exit the game and we use the gamepad state. Update the camera, move the player, rotate the player, and enable the shake. Now, I used B in this case because S is currently for the camera, WSAD, so I thought B was for like a bomb, so that can be used for the shake. We throw a bomb and it shakes the camera. Remember, shake, the amount, the time it will last, the position offset, and the rotation offset. And then we have a string builder class to create a nice looking string to display. Camera controls, all the buttons here. Player controls, all the buttons here. And then we set that to the info string. Now we draw. Now we draw by using the sprite batch.begin that accepts a transform matrix. The sprite sort mode.deferred and blend state alpha blend are default values. Then we can do null, 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 and then the camera.transform. Now we want the background and the player to be transformed only. So we create a separate begin and end cycle here to just draw the string information. Because we want the string to stay where it is no matter what the transform matrix is. So we just create a new begin and end. to have that result. Alright, so 15 minutes of going over the code. You want to see the end result. Let's press F5 to build and run it. Okay. So, for the player controls, arrow keys, move up, move down, move left, move right. N is rotate counterclockwise. M is rotate clockwise. And Z is zoom in the camera. X, zoom out the camera. W, SAD, move the camera. Remember, the sprite, the player sprite, the spaceship, stays the same because we're just moving the camera. We're manipulating that transform matrix, so everything should stay where it is, except for the camera. So WSAD, alright, now let's shake it. We press B, we shake it. And rotation is a little bit too short, I think. But you see the position has a nice shake to it, because that's at 5. So let me zoom in here. And also, the further you zoom in, the slower the movement will take. When you zoom out, the faster the movement will take. And I need to build a reset button, I think. So I just lost that here. So I zoom in, I move it. It's a little bit slower. I zoom out. I can move it. It's very fast. Alright, so B is shake, and you can hold down the B button. And we'll just keep on shaking. So I thought that was pretty interesting. There is a dedicated class. All you need to do is what you saw in the game1.cs is to create an object of the camera, initialize the camera, create a new camera object by passing in the viewport you want and the initial position you want, which if it's 0, 0, which is vector2.0, it will be the center of that viewport. And in the update method, just update it, and it will take care of itself. Oh, and of course, you need to have a begin that uses that camera's transform matrix. See, if we take that out, it'll just be nothing special will be different. Alright, that's it for this sample. Also, I am going to start providing the repositories that you can download using Subversion. I'll make a separate video about that. But on the YouTube description or on the forum post on this video, I will post a link to the Subversion URL for the samples repository. So you can use a Subversion client to download all these samples, and it will be up to date. I do some changes every once in a while, and you just do an SVN update to get those changes. I already have a Subversion video available, but it was about 2 years old, and I didn't really get into the whole video kick at that point, so it's pretty poor quality video. But if you want to see it, it's on the forums. I did not upload it to YouTube. I will create a different video about Subversion later on. That'll be probably next week or 2 weeks from today. So at the end of this video, inside the YouTube description or the forum posting, you will see a link to this Subversion repository. So you use a Subversion client, and then I use Tortoise SVN. So if I create a new folder here, new, I do an SVN checkout, and I use that URL, and there you go. And that's one of the URLs that you can write down if you want to. Just space reset. Alright, so I have a lot more repositories than these. These are just what I work on my PH Studio's computer. Just XNA stuff. On the Mac side, I have all the Photoshop, After Effects, all those repositories as well. Screen System, if you want to download that. If you do download it before I release a Subversion video, I do the usual trunk is where the main development code is, so you can get all the code here. So that was trunk. Tags are the kind of like versions of that trunk file. So I can have beta 1 here, beta 2 here, full release here. But I do not do the betas. So whatever you see in the trunk, I make a zip file and I just put that in the tags. Because you can browse that repository with a browser. So you can just go to the tags and download the latest tag. And branches are what I use for, let's say, the particle system. Somebody wanted the bubbles menu again, so I just did a particle system, the very basic operations of a particle system, and then a branch is to take that further, and I created the bubbles menu. So that's the difference, what I use for trunk tags and branch. A branch is taking an existing trunk code and changing it to a specific type or a specific version. Tags are whatever is in the trunk, and I right-click, send to zip file, and release that in the tags. That's pretty much it. You do not need to get Subversion to get this sample that I just created. I will release a dedicated zip file, and that you can download just from the PH Studio's website. Just like the past, you've seen the YouTube description, download source here. Click that. I will release that the same way. Alright, that's it for this tutorial. Next weekend will be another one tutorial for XNA. And the next tutorial for today will be the Photoshop tutorial. So I hope to see you next time.